And good day to our beloved Professor Christian Cabin Larisma. Today, I am your first reporter in linear algebra. So, I am Alan Martin Rochi Breheldo, and I will report about system of linear equation. Today, our intended learning outcome, or the ILOs, so at the end of the sessions, the mathematics students should be able to do the following. First, solve different kinds of linear system using elimination method. Second, apply linear system in automotive and food technology. And third, apply linear system in electricity and machine shop. Again, at the end of the sessions, the mathematics students should be able to do the following. First, solve different kinds of linear system using elimination method. Second, apply linear system in automotive and food technology. And third, apply linear system in electricity and machine shop. So, linear equation. So, first, we should define linear equation. Linear equation is an equation in which the maximum degree is 1. Or, we can say that a linear equation that has only one variable is called linear equation in one variable. We can identify linear equation if the maximum degree of a variable is only 1. And we can say that if the equation has only one variable, it is called linear equation in one variable. For example, y is equals to 2. So meaning, there's only one variable in the equation. So it is called linear equation in one variable. Another example, x plus 2y is equals to 3. So there's two variables. So as what you can see, it is also a linear equation because the maximum degree of the variables is only 1. So that's why it is a linear equation. When we say about nonlinear equation, it is an equation where the maximum degree of a term or the minimum degree of a term is 2 and it is or more than 2. So if the degree of the equation is more than 2 or 2, it is nonlinear equation. For example, x squared plus y is equals to 3. As what you can see, the degree of x is squared. So therefore, it is nonlinear equation. And the next is x4 plus 22y is equals to 5. So, x raised to the power of 4, meaning 4, it is nonlinear equation because it's more than 2 or 2. So, lesson number 1, solving linear system using elimination method. Using elimination method, you either add and subtract the equation to get an equation in one variable. Our main goal here is to get an equation in one variable. For example, so here, we have 3 types of solutions in elimination methods. So these are infinite solution, no solution, and unique solution. When we say infinite solution, there are many solutions in the equation. And if it's no solution, meaning there is no solution or there is no solution in the equation. And then third, unique solution, so meaning the solution is only one. So here, for example, so x1 minus 3, x2 is equals to negative 7. This is the equation 1. And then 2x1 plus x2 is equals to 7. This is the equation 2. So our main goal in elimination method is that we should have only one variable. So we need to eliminate the other variable. In this case, we need to eliminate x1. So in order that we can eliminate x1 to equation 1 to equation 2, so we need to multiply 2 to the equation 1. So 2 times x1 minus 3x2 is equals to negative 7. So it will become 2 times x1 is 2x1. 2 times negative 3 is negative 6x2. 2 times negative 7 is equals to negative 14. So now, we can eliminate this one with 2. But we need to multiply negative to equation 2. So negative times 2x1 plus x2 is equals to 7. So through that, we can multiply negative. So it will become negative 2x2 plus minus x2 is equals to negative 7 because we multiply with negative to the equation 2. So through that, we can cancel x1 in the equation. The remaining is x2 in the variable. So negative 6x2 plus negative x2 is equals to negative 7x2 is equals to negative 14 plus negative 7. It will become negative 21. So in order that we can get the value of x2, we should divide negative 7. So negative 21 divided by negative 7, the x2 is equals to 3. So the value of x2 in the equation is 3. So now, we can substitute the value of x2 in the equation 1. So x1 minus 3x2 is equals to negative 7. Substitute. So x1 minus 3 times 3 is equals to negative 7. 3 times 3 is 9. So x1 minus 9 is equals to negative 7. So transpose x1 is equals to negative 7 plus 9. So x1 is equals to 2. So therefore, x1 is 2, x2 is 3. So thus, it is a unique solution because it has only one solution. Another example, example number 2. So the equation 1 is x1 minus 3x2 is equals to negative 7. And then the equation 2 is 2x1 minus 6x2 is equals to 7. Our main goal here is to eliminate other variable in order to get one variable in the equation. So we should eliminate x1. So the same process, we need to multiply equation 1 with 2. So 2 times x1 minus 3x2 is equals to negative 7. So it will become 2x1 minus 6x2 is equals to negative 14. In order to eliminate the x1, we need to multiply negative to equation 2. Negative times 2x1 minus 6x2 is equals to 7. Here, negative 2x1 plus 6x2 is equals to negative 7. So we can cancel x1. However, in the equation, the x2 is also the same. So we can also cancel x2. So here, the variable is 0. 0 is equals to negative 14 plus negative 7 is negative 21. If the variable is 0, the equation is no solution. There is no solution in the equation. So another example, example number 3. So equation 1 is x1 plus 3x2 is equals to 3. And then equation 2, 2x1 plus 6x2 is equals to 6. And then now, we should eliminate x1. So by multiplying 2, the same process. 2 times x1 plus 3x2 is equals to 3. It will become 2x1 plus 6x2 is equals to 6. The same process, we need to multiply negative to equation 2. Negative times 2x1 plus 6x2 is equals to negative 6. So here we can cancel x1 and x2. However, we can also cancel 6. So, the remaining is 0 is equals to 0. If in that case, it is infinite solution. If 0 is equals to 0, it is infinite solution, or there are many solutions in the equation. So now we will move to application of linear system in food and automotive technology. A linear system is a mathematical model of a system based on the use of linear operator. Linear systems typically exhibits features and properties that are much simpler than the non-linear case. As a mathematics abstraction or idealization, linear system find important application in many different fields, including food and automotive technology. So, food and automotive technology, it is a science. Food technology is a science branch that deals with different techniques involving production, processing, preservation, packaging, labeling, quality management, and distribution of food products. The field is also involved with techniques and processes that are used to transform raw materials into food. That's the food technology. Automotive technology is the practical application of knowledge about self-propelled vehicles or machines. Students studying automotive technology learn about engine, construction, fuel and ignition system, powertrains, brakes, transmissions, electronic and diagnostic equipment, and many more. So again, food technology about food. Automotive technology is about engine, in construction, fuel and ignition system, and many more. So we should apply linear system in food technology and automotive technology. For example, here, so we apply linear system in automotive technology. So sample problems. For Ramon usually gets one routine maintenance option at Annie's garage today. However, he needs a different combination of work than what is listed. So here's the listed. Routine maintenance options, so for oil change and radiator flush is $299. Brake pads and oil change is $399. Oil change, radiator flush, so and brake pads replacement is $499. So assume that the price of an option is the same price of purchasing each items separately. Find the prices for an oil change, a radiator flush, and brake pads and replacement. Brake pad replacement. Another, if Ramon wants his brake pads replaced and his radiator flush, how much he would spend? So here is the solution. Let X, Y, and Z be the price for oil change. Again, X, Y, and Z. Variables X, Y, and Z be the price of oil change. Brake pad replacement and radiator flush. Then, X plus Z is equals to $299. And then X plus Y is equals to $399. And x plus y plus z is equals to 499. So we need to substitute 399 for x plus y in the third equation and solve for z. So we need to put 399 to x plus y in the third equation, which is x plus y plus z is equals to 499. So x plus y, substitute 399 plus z is equals to 499. So transpose. So it will become z is equals 499 minus 399. So z is equals to 100. Substitute 100 for z in the first equation and solve for x, which the first equation is x plus z is equals to 299. So z is equals to 100. So x plus 100 is equals to 299. So 299 minus 100 is x is equals to 199. And then now we can substitute 199 for x in the second equation and solve for y. So x plus y is equals to 399. So 199 plus y is equals to 399. So y is equals to 399 minus 199 is 200. So thus, the price for oil change is 199 pesos. Brake pad replacement is 200 pesos. And radiator flush is 100 pesos. So B, the cost of brake pad replacement and radiator flush are 200 pesos and 100 pesos. So that's why he should spend 300 pesos. Note, you may solve the system using any method. So you can also use elimination method. You can also use the matrix as long as you apply linear algebra. So in food technology, example, here, ABC Food Company wishes to produce 3 types of instant noodles. So again, ABC Foods Company wishes to produce 3 types of instant noodles. Types A, B, and C. To manufacture type A noodles required 2 minutes on machine 1, 1 minute on machine 2, and 2 minutes in machine 3. At type B noodles requires 1 minute in machine 1, 3 minutes in machine 2, and 1 minute in machine 3. A type of C noodles requires 1 minute on machine 1 and 2 minutes each on machine 2 and 3. So there are 3 hours available in machine 1, 5 hours in machine 2, and 4 hours available in machine 3 for processing the order. How many instant noodles of each type should ABC Food Company makes in order to use all of the available time? So here is the table. So solution, the given information may be tabulated as follows, or the table. So here, type A, type B, and type C. Time available here. So machine 1, type A is 2. Type B is 1, and type C is 1. And then time available is 180. Because 2 minutes in machine 1. So it 180 seconds. And machine 2, type A is 1, type B is 3, type C is 2, and then time available in minutes is 300. Machine 2, type A is 2, type B is 1, type C is 2, and then time available is 214. Again, machine 1 is 2 hours, not 2 minutes. Okay? Here, Ano? There are 3 hours available in machine 1. That's why 180 minutes, because 1 hour is 60 minutes. So we have to determine the number of each of the 3 types of instant noodles to be made. So let X, Y, and Z denote the respective numbers of type A, type C, and type B, and type C noodles to be made. The total amount of time that machine 1 is used is given by 2x plus y plus z minutes and must equal to 180 minutes. This leads to the equation of 2x plus y plus z. Similar consideration on the use of machine 2 and 3 lead to the following equations. So x plus 3y plus 2z is equals to 300. 2x plus y plus 2z is equals to 240. Since the variable x, y, and z must satisfy simultaneously the 3 conditions represented by the 3 equations, the solution to the problem is found by solving the following system of linear equation. So here's the equation. First equation is 2x plus y plus z is equals to 180. Then second equation is x plus 3y plus 2z is equals to 300. And then third equation is 2x plus y plus 2z is equals to 240. Here, solving the foregoing system of linear equation using Gauss-Jordan elimination method, we obtain the following sequence of the equivalent or augmented matrices. So we should use the Gauss-Jordan elimination. So in solving the problem, so in the equation 2, 1, 1, and then equation 2, 1, 3, 2, and then 2, 1, 2. In equation 1, 180 minutes, 300, and 240. So here, as what you can see, here we just put the equation in the matrix. So you need to get the identity of the matrix. Here, you need to get the identity. In order to get the identity, you must use operations and the matrices. So here, the answer is x is equals to 36, y is equals to 48, and z is equals to 60. That is, ABC Food Company should make 36 type A noodles, 48 type B noodles, and 60 type C noodles in order to use all available machine. Note, any methods can be used in solving the system of equation, including elimination and substitution. So here, he used the Gauss-Jordan elimination method. So now, we will move to application of linear system related to electricity and machine shop technology. The system of linear equations are used and determine the currents through various branches of electrical networks. Junction, all the current flowing into a junction must flow out of it. So path, the sum of IR turns in any direction around a closed path is equal to the total voltage in the path in that direction. So here, the resistor is here. Resistor, then 15 voltage and 20 voltage. So current is equals to the flow of rate of electrical charge. Current is measured in amperes. 1 amperes is equals to the electrical charge of 6.2 times 10 raised to the power of 18 electrons per seconds. Goal, we need to compute the current 1, current 2, and current 3. Here, we need to compute the value of I1, I2, and I3. So, in order to get the answer, you must use Kirchhoff's first law. Flow into a junction and flow out of junction. So, first, you need to plus I1 plus I3 is equals to I2. And then second equation, I2 is equal, it will become I2 is equals to I1 plus I3. So, I1 plus I3 is equals to I2. And use the Ohm's law, which is voltage drop is equals to I times R. So, here, I1 plus I3 is equals to 2. Ohm's law, and then use Ohm's law and Kirchhoff's second law. So, that's why we can get the upper loop, which is 15 minus 2I1 minus 4I2 minus 5I1 is equals to 0. And then the lower loop, 20 minus 4I2 minus 2I3 is equals to 0. So now, we get the three equations. So, first equation is I1 minus I2 plus I3 is equals to 0. The second equation is 7I1 plus 4I2 is equals to 15. Third equation, 4I2 plus 2I3 is equals to 20. So, you also use the Gauss-Jordan elimination. So, here, you need to get the identity. So, using the row reduction, the answer is 0.2, 3.4, and 3.2. So, how to compute the currents in electrical network? So, first, electrical network. And then use the Kirchhoff's first law, which is junction, and then Kirchhoff's second law, loops. System of linear equation, using system of linear equation, and then solve. And then there's the value of current. So, I1 is equals to 0.2. I2 is equals to 3.4. I3 is 3.2. You can also use elimination and substitution method as long as you can solve the value of currents. So, note, 15 voltage is positive and negative 15. And then 4 ohms is 4 current times 4 times negative I1. So, in order to solve this one, so it will become negative 15 minus 5 I1 minus 4 times negative I2 minus 2 I1. Simplify, it will become negative 7 I1 plus 4 I2 is equals to 15. So now, we will use linear system application for machine technology. So, Hansel, Chief System of Sales and Sales Officer, BMG Mori, sums it up perfectly. Go into any shop, ask them if they want to automate. The answer is yes, 100%. But what kind of automation? And which machine and processes? For a wide variety of companies, the logical answer is linear pallet system that integrates multiple metal cutting machines, possibly additional operations. On the other hand, logical doesn't always mean easy or worry-free. A basic linear pallet system is also known as flexible manufacturing system, or FMS, automates the loading and unloading of one or more machine centers with work pieces from a central storage location. The work pieces travel on a straight rail carried by the vehicle with additional axis of motion that enables it to move the work into a machine and onto the table and out again. When finished, operators set up jobs at the central station, not at the individual machine. And the central computer controls the distribution and execution of work. Dawson linear palette system features the straightforward user interface, control shown to the left, and an overhead bus to the supply high voltage 3-phase power to the pallet vehicle without cables, which are wired to breakage. So that's the application of linear system in machine shop. So here is your evaluation. So direction, solve the following linear equations using elimination method and then identify the following if it is unique. Infinite solution, show your complete solution. So first equation is 2x1 minus 2x2 is equals to 6. And 3x1 minus 3x2 is equals to 9. So second, a dietitian is preparing a meal consisting of foods A, B, and C. So don't worry, I will post this one in our Google Classroom. So that's all for today. Thank you so much for listening and I hope you understand our lesson for today. Thank you so much and God bless us all.